All right, welcome to Unit 3. This is our first ed puzzle for this unit. So let's talk about linear relationships. So in the past, starting in 6th grade, you started with working with table of values, input and output values based on a relationship. And that's where we're starting for 8th grade. We have a learning target that you see before you. I will be able to define and identify a function, as well as create mapping diagrams from the set of input and output values. Now remember, this learning target is going to lead us over 5 days of learning. So you might have heard that and read that and say, I have no idea what that means. Well, no worries. We will be working on this learning target over the next week and a half, where we will end with our quiz, which will be your demonstration of knowledge based on that. This also is part of our curriculum. It's a learning standard. I know it's foreign to you, but it's called 8F1, 8th grade functions. And this is our first standard. And it's about functions. So this does relate to our curriculum and will support you next year moving into 9th grade algebra. So let's move on to see what this is all about. So day 1, lesson 1, that's today. So we're going to discover what is a function. We're going to look at a lot of vocabulary and things like that. Tomorrow, you're going to do a day 2 of practice. So your notes based on today's lesson and your practice, which is one example problem you're going to do at the end of class today, you will use that knowledge to show and demonstrate understanding for tomorrow's practice. So that means, guys, if you think of it, yes, you're going to need a piece of paper and a pencil. You're going to have to take notes during today's video. The Ed Puzzle will stop and ask you questions. Those questions will help you discover and practice the learning target for today. You're going to need to complete each step on that lined piece of paper while you're taking notes, and that will help you be able to draw those mapping diagrams and turn in that final question for today's practice. And again, help you for tomorrow. So let's jump right in. So what's a function? Now, some of you might have heard in the past a function machine. Now, this is something that shows a relationship, and a basic rudimentary machine, let's say it's a rectangle, and at the top of this machine, there is a place that you can put in values, and we call those input values. And once they get processed within the machine and a relationship of whatever that machine does, let's say it's a refrigerator, and we put water in our refrigerator and we open up the door and it's still water after a couple hours. But what's the difference if you put that water inside of a freezer? Is there a different relationship between the water in the freezer compared to the water in the fridge? And that's what we call function machines. Well, if we put numbers inside the machine, then we should also have some sort of exit. And we call those exit values output values. So we look at many different things. We study the input and what kind of numbers can we put into this machine. We study what's the machine doing, what's the relationship that it's performing on the input to produce those output values. And then we look at the output values and say, wait a second, is this machine actually working? So let's look at this function machine right now. And let me get a pen out, a little bit darker. All right, so we have an input here. Let's say we put in the number 2. And I'm not going to tell you what's in the machine, but I'm going to tell you what comes out of the machine. So 2 goes in, and all of a sudden, the machine works. And then all of a sudden, out comes a 10. And you're like, all right, I don't really know what's going on in the machine yet. I have some ideas. Maybe it's adding 8. Maybe it's multiplying by 5. Maybe it's adding, multiplying by 4 and then adding 2. Remember, there could be a lot of different things happening inside this machine, but the best way to figure out what is happening in the machine is to put in another input value. So if I put 4 in and I wait, the machine works, and then out comes a 20, I might have a better idea of what's going on. So that would be basically, what is that relationship inside? What is happening to my input values, which are my independent variables? What's happening to those in my machine? to actually spit out of this machine a 10. That relationship inside needs to still be true for when you put a 4 in and get a 20, or when you put a 7 into the machine and out comes a, hopefully you know, a 35. So what is happening inside that machine? And that is a look at the relationship between the input values and the output values. So does anybody know what that relationship is inside? Hopefully you do, and that is multiplication by 5. So we take that input value, which is known as x, and we multiply by 5 to get our output value. So normally it doesn't look like this. Hopefully you know proper format would be 5x. So 5x. So our input is our x values, and our output, what do you think letter would that be? Our y values. So that means once I put an x in here, it gets multiplied by 5, and then it becomes my y value. So when 2 goes in for x, gets multiplied by 5, and then y becomes 10. And when 4 goes in, 4 times 5, output 20. So hopefully you remember this, and this has been building through the years, through beginning in 5th and in 6th and in 7th, and now we're really going to start studying it in 8th grade. So let's clear this out and let's see what our next slide is. So we're going to start here first with our vocabulary. We're going to figure out what is a relation. So we got to start with the definition of relation to make sure that we understand what is actually happening. So what is the definition of a relation? Well, a relation between any two sets is a collection of ordered pairs. So a relation is a collection of ordered pairs that contains one element from the input and one, element from the output. So if we think back to what we just did from our function machine, we have input values, and I put 3 of those input values in, 2, 4, 7, and I left out 11, but that would be another input value I could put in. So this is called set notation. And within set notation, you can see it might be a new symbol for you, but we use this right here, these set notations, and these are called braces. So they're not parentheses, but they have a little squiggle to them. Those are called braces. And we use braces when we list our input values. Okay, so if we use those set notation, we have to do that and say, okay, so what did you put in this function machine? I put in a 2, a 4, a 7, and 11. What do you think would happen next? Because if we have to state the input values, then hopefully you know that we should state something else. Well, before we get there, what are other names for input values? Well, other names for input values are the x values, or we can also call them independent variables because we get to choose what goes into the machine. So they're independent. There's also a fancy word you're going to learn in 9th grade, which is called domain. So our input values have 4 different names that we refer to them as: x values, independent variables, domain values, and input values. Now, I am going to use multiple combinations of those words to get you comfortable, and I know your other teachers will as well. So going back, if I list my input values in set notation, I probably should also list my output values in set notation. Now remember, the relationship that we used was our times 5. So if 2 goes into the machine, then I need to state that 10 comes out. And that output should be in the same order in which my input goes in. And since my input is increasing, my output increases as well. So I have 2 times 5 is 10. That's the first output value that's associated with the first input value. So this is a set of output values. Those are all the y values. And remember, a relation between 2 sets. So here's my input and here's my output. Those are 2 different sets. Is the collection of ordered pairs. Well, I haven't made ordered pairs yet. I do have the input separate listed and the output, but how do I relate them together? And that's why we call them a relation. But before we get there, what are some other words that we call output? Hopefully you remember the first two. Our output is called our Y values, our dependent variable, and here's that fancy word they're going to use in 8th grade. It's called the range values. So output has 3 other names that your teachers are going to use to get you comfortable with vocabulary. So if I put these things together to make a collection of ordered pairs, I need to do that in set notation. So a set of ordered pairs would have my braces, and it would be X's and Y's, one element from each of our sets. So one X to one Y. Now that X and Y has to have that relationship. So the X is what you're putting into the machine, and then all of a sudden, the Y is what comes out from that number. So when we build the set of order pairs from this list of input and output, I get something that looks like this. It's in set notation. You can clearly see that I have the first ordered pair. 2 went into the machine and out came a 10. 4 went into the machine, 20 came out. So these are the sets of ordered pairs. And because it's a set, we keep it in set notation. See this little braces, that's what makes it set notation. And therefore, since I have all of my input and output values combined into a collection of ordered pairs, and I have one element from each set, what did I just make? I just made a relation. And that's what a relation is, a set of ordered pairs that comes from a machine of some sort. And that machine is what we're going to study, that relationship and the input and output values. One important thing not to forget while you're doing this today is to make sure to use set notation. Use those braces when writing input and output values as your list, as well as making those set of ordered pairs in our relation. So those braces are huge because, again, the definition talks about sets, and we use that for set notation. So hopefully you have that written down all in your notes because we are going to move on to, all right, so if I know what a relation is, so what's the function? So let's look at that next. So what is a function? So again, we start at our vocabulary. So a function is, oh no, it didn't come in order. We're going to check to see if this is a relation or a function. That one's snuck in there. So a function is a relation from a set of inputs and a set of possible outputs. Wait a second, that's what we just talked about. A relation is the set of input and output values written as ordered pairs. But a function is more than that. So a function is a relation, but even more because there's a special property that goes in there. And that next step is where each input is related to exactly one output. So that means that each input value needs to go to exactly one output value. That's what makes a relation turn into a function. Now you might say, Ms. Anderson, you're way too excited about this and I have no idea what this means. Well, that's why we practice. So I have an example for you here. Is this relation actually a function? So if it is a set of ordered pairs, it's automatically a relation. But does it meet this definition of a function, which says each input value is related to exactly one? Now that's a specialty. So let's look. So I kind of use some emojis here. If this shoe goes into the machine and out comes a football. If this goes in, out comes the soccer ball. If ballet shoes come in, out comes the basketball. If sneakers go in, out comes the volleyball. So I know you might be like, well, what kind of machine is this? But let's look at it. This blue flat makes football. This boot makes soccer. Ballet makes basketball. And tennis shoe or sneaker makes volleyball. So those are our sets. So let's look at a little bit more details here. So if that is my set, which is called my relation, what are my input values? So if I have to pull my input values out of here so that I can see them, what would they be? Would they be shoes or would they be the sports, different balls that we have? Hopefully you said that, well, the input would be our X values, and the X values always come first in our ordered pairs. Therefore, our input values are our shoes. And that's a blue flat, a brown boot, ballet slippers, and tennis sneakers. So what are our outputs then? You are correct. Those are our sports balls that we use for different types of sports. There's a football, there's a soccer ball, there's a basketball, and there's a volleyball. So those are our output values. That's what's coming out of the machine when I'm putting these shoes in. Now let's check. Is this relation actually a function? Well, it says that if each input is related to exactly one output, so that means that this shoe only goes down to that football, and this boot only goes to soccer, and this ballet only goes to basketball. So this shows that each input value has exactly one output value. So what does that mean? That means that yes, this is a function. So I think maybe we have to figure out what's not a function so that we understand what is a function. And that's my next example for you. So let's look at something that's not so that you can see what it is. So I'm going to give you another example. Is this relation a function? So I'm going to give you the same type of thing. I'm going to give you shoes as your input and different sports balls that we use. And now you can see that this is a different build of a relation. Remember, a relation is a set of ordered pairs. So let's look. What are my input values? Well, my input values in this case is a blue flat, a brown boot, ballet flats, and a brown boot. Well, that brown boot repeated itself. So in my input values, I technically only have 3 different input values. I put in the blue flat, I put in a boot, I put in a pair of ballet shoes, but then I put a boot back in. I could do that. Remember, I could have put 2 in there multiple times or 3 inside that function machine multiple times. It's the relationship that matters. So this is a relation, but when I look at that output, what is the output? Well, my output is a football and a soccer ball and a basketball and a volleyball. So let's look at the relationship. So my blue flat goes to my football. My boot goes to my soccer ball. My pink ballet goes to my basketball. But the boot also goes to my volleyball? Well, that doesn't make the definition true. Each input is related to exactly one output, and that is not the definition. So what does this mean? This means kind of like if I put a boot in a machine and it's associated with a soccer ball, that every single time I put a boot into that machine, a soccer ball better come out if it's functioning. But if one time I put in the same boot and out comes the volleyball, I'd be flabbergasted. Wait a second. This machine doesn't seem to be functioning. That's going back to our example of the water in the freezer. What if I put water in the freezer and out comes, I don't know, a lollipop? When I know in my brain that every time I put water in a freezer, that an ice cube comes out. What if one day a lollipop came out? You'd be like, wait a second, something is wrong with this machine because it's not doing what's expected to do. And we call that not functioning. It might be really cool that now you have lollipops coming out of your freezer for water, but again, it's not a functioning machine. So our function is when each input value, and you can see that, goes exactly to one output value. When an input value actually gives you 2 different outcomes, that's not a functioning machine. Is it a relation? Yes. It's still a relation, but it's not. Oh, I have my red arrows there to show you, but that is not a function. So if I say, is this relation a function? I would say no, it's not a function, but it is a relation since it is a set of ordered pairs. It's just not meeting that extra detail that a function calls for. So hopefully you're getting a gist of what a function is and making sure that each input value only has exactly one output value. My boot cannot repeat and give me two different outcomes. That's when it's not functioning. So let's look at something else. Let me clear this screen so that it doesn't come with us on the next one. All right, so I left that title up there for you. A function is a relation from a set of inputs to a possible set of output values where, and this is the kicker, where each input is related to exactly one output. The beginning of that definition is just the definition of a relation. So let's look at this problem. All right, so we have relations and functions. What's the difference? Every function is a relation, but not every relation is a function. And that's where we have to know our vocabulary. So here's a set of ordered pairs. So automatically, I know that that set of ordered pairs is a relation. There is an X and a Y, and there is a relationship between these numbers. I don't know what it is just yet. If I looked at 2 to 3, I would think maybe +1, but then I look at 5 and 4 and I'm like, oh no, I don't know what it is. But we're not looking at the relationship between it. We're checking to make sure that each input value has exactly one output value. So let's look. So we're going to say, is it a function? Well, to check of a function, remember, you need to go through the X values. 2, 5, 4, 0. Oh, sorry, I said 4. 2, 5, 0, 4, 1. Those are my X values. Remember, the X value is the first value in an ordered pair. And then my 3, my 4, my 3, my 1, and my 2 are my output values. So to be a function, I need to make sure to check each X value is unique. Remember that boot went to my soccer ball and the boot went to the volleyball? That makes the boot not unique. So I need to quickly check. So I'm going to check, is 2, 5, 0, 4, 1, are all of those unique values? And hopefully you said yes. So let's look at our input. So just like I said, remember, list all of the X values in set notation. Remember, you need those braces. You need to see those braces to begin and to end your list. As well as, here's a new tidbit, your input needs to be in numerical order. Now, if I look up here and I see my 2, my 5, my 0, my 4, my 1, those are not in numerical order. So what I usually do is I set up my set notation and I go through and I look for that smallest number and I can see it's 0. So I'm going to list my 0 and then I'm kind of going to exit off because I took that one into consideration. So I go through and I make sure that I have all of those input values listed, and there it is, 0, 1, 2, 4, 5. And that's in numerical order, and it is in set notation. Those are my input values. So let's also check our output values. Now remember, our output values represent which variable? Hopefully you said yes. Y values are listed in set notation in numerical order with no repeats. This is another huge tip that you need to know about output values. You cannot repeat them. So if for some reason a input makes multiple outputs, that's okay. You just can't write them with repeats, and it needs to come in numerical order. So I'm going to go back up here, and I have a 3, a 4, a 3, a 1, and a 2. So I do have a repeat here, but I'm not going to write that. So again, I would set up my set notation, and I would say, all right, what's my smallest number? 3, 4, 3, 1. Oh, that's 1. So I'm going to cross that out to make sure I'm putting it in a list. And I go through to make sure I have those in numerical order. And my output range is 1, 2, 3, 4. And that's incorrect. And I did not repeat that 3 because I cannot repeat values in my output. Now let's check on our function. So let's see, 0, and we use our ordered pairs here. 0 goes to the 3. Okay, so I did that one. And a 1, the 1 in the X goes to a 2. So I can map the 1 to the 2. And then that one's out. I mapped that one. And the next one, let's go from a 2 to a 3. So the 2 goes to a 3. And continuing, the 4 goes to the 1, and the 5 goes to the 4. So I can see that out of each of these input values, I only have one path because it only goes to exactly one output. There's only one arrow coming out of each of these input values, which justifies and validates that, yes, this set of ordered pairs, which is known as a relation, is a function. But this is kind of hokey, this kind of look to it. So they changed it and they give you something called a mapping diagram. So this is what you're going to practice on your paper. Now, a mapping diagram looks similar to this. You have two circles that you use, and you have one on the left side and then one on the right side. And then if you think of it, it kind of looks like a table of ordered pairs. And this was the beginning idea of tables. Our first values are going to be our X values. So the circle or oval to the left will represent my input values. And we do those in numerical order, but instead of left to right, we do them top down. And then our right side oval of our mapping diagram will represent our output values, which in this case, in numerical order, with no repeats, is our one. Oops, I got to change that to my pointer, which is our 1, 2, 3, and 4. And you can see those up there. Now, yes, you're right. 3 repeats itself, but we do not list that in the output, and we do not list that in our mapping diagram for our output values. So now how do we use the mapping diagram to help us validate that this is a function? And we do the same thing we do right here. We go through our ordered pairs and we map. 0 gets mapped to a 3. So therefore, we draw a 0 to a 3. Oh, I started here. 2 goes to 3. So 2 goes to 3. 5 goes to 4. So I map 5 from the X, gives me an output of 4. 0 goes to 3. 4 goes to 1, and you can see that. And the last one, 1 gets mapped to 2. Now, for me to validate if this is a function by a mapping diagram, I need to make sure that each input value has exactly one arrow coming out of it. Since each of these input values has one arrow, that means it's mapped and related to exactly one output value, and that is allowed. So hopefully you're writing all of this down. I have another example for you to try. Let me erase this and let's move on to the next one. All right, so you can see up in the upper right-hand corner, this is a you try. So there's going to be a lot more questions for you to answer and to work through. So the first thing, I have the vocabulary right up here so that you can use it and remind yourself what it is. So we're going to work with relations and functions, but the first thing you need to know is, what is my relation? What are these numbers that I'm working with? So here is your relation. And what is a relation again? So let's go through this. Is this a function? What do we have to do to check? We need to check to make sure each X value is unique. That's our overall goal. And we do that in many different ways. Do you think it's a function? Ah, you're saying it is. Well, let's see. The input values. What is the input values and what do they need to be written in? All of the X values listed in set notation, those are your braces, in numerical order. So what does our input look like? Yes, in numerical order, we have -2, -1, 0, 1, 3 as our X values within our relation. So what are our output values? Output values are all of your Y values from your relation listed in set notation in numerical order with no repeats. Again, that's a huge importance and difference between input and output. So what does our output look like? Hopefully you wrote that in there. -12, -4, 0, 4, and 8. In this case, I didn't have any repeats, and I needed to make sure it was in set notation with our braces, and we needed to make sure it was a numerical value. So if we have our listed input values and our listed output values, we can make a mapping diagram from this. So remember, what is a mapping diagram made up of? two ovals, one on the left that represents my input values listed in numerical order from top to bottom, and a right oval that's listed our output values from top to bottom. Now we have to start mapping a -2 to an 8. Oh, let me see if I can go back one. Can I go back one? Oh, yeah. So I need to get my pen. That's what I missed. So my -2 goes to my 8. So I'm going to draw my mapping diagram. 1 goes to -4, 3 to -12, 0 to 0, and -1. Oh, I messed that up. Did you notice I just messed that up? I'm so glad I make mistakes so that you guys can see that I'm human here too. -2 to 8, +1 to -4. That was my error. There we go. 3 to -12, 0 to 0, and -1 to +4. Everybody makes mistakes. Yes, don't sing the song. But yes, now let's quickly check our mapping diagram for each of my input values. Do I have one arrow coming out of my input values? And I do. That means that this relation is a function, and that was correct off the top. Remember, you can quickly check by studying the x values within your relation and making sure that each of those are unique. That means they don't repeat. So if you have unique x values, you have a function. If you have repeating x values, you do not have a function. You only have a relation. So I think I have one more for you. Let me clear this up as a you try. Yep, I do. Here's a you try number 2. We're still studying our relations and functions. Here's our set. We're going to go through the same thing. Do you think that this relation is a function? No, it is not. Well, let's look at it. Let's look at the set of input values, which are all of your x values listed in set notation in numerical order. And let's do our output values as well, which are all of our y values listed in set notation in numerical order with no repeats. And what does that look like? There it is, -1013. So it looks like something is going on. I have 3 input values, but I have 4 output values? That seems strange. Does that imply that one of my input values actually repeats, which makes it not unique, which makes it not a function? But let's look at the mapping diagram and see if we can do that. Mapping diagram is made up of 2 ovals, one on the left and one on the right. The one on the left is made up of your input values in numerical order from top to bottom. And your oval on the right is made up of your output values, top to bottom, numerical order. So now let's grab our pencil and let's draw this mapping diagram. So a 4 goes to a 0, a -2 to a 1. Make sure I get the signs right this time. 3 to a -1, -2 to 0, and 4 to 3. So let's look. I have, for -2, I have 2 branches. For 3, I have 1. And for 4, I have 2 branches. No, not allowed. Remember, each x value needs to be related to exactly one output. These 2 branches right here, not allowed in a function. This one, that's cool. That's allowed. But no, you fail here too being a function. This branch going to 2 different, not allowed. So you can be a relation, but I'm sorry, you don't meet this separate specialty of meaning to be a function. You are not. And this mapping diagram justifies our no, making sure that our x values are unique. They're not unique there, and they're not unique here. They repeat. There's another sign that this relation is not a function. The mapping diagram gives us a different visual of why it's not a function. And looking at, wait a second, 3 input values produce 4 output values? That can't work. So there's many different views that's trying to tell you with understanding that this relation is not a function. So what's the final task for today? Your final task, oh no, let's clear the screen off. Your final task is to complete the problem that I'm going to give you below and upload a screenshot to Google Classroom. So what are you going to do? You have to first state the input values and the output values in proper notation. We just did that. Hopefully you remember what proper notation means. Show the mapping diagram for the set above I'm about to give you. And then state if that set is a relation or if it's just, if it's a function or just a relation. So what does your set look like? Is this following set of ordered pairs a relation or a function? So those words should seem a little bit more understandable for you. But remember, that learning target about understanding is not due until the end of day 5. So let's look at it. There is your set. Make sure you do step A, B, and C. I'm going to pause this and give you a little bit of time. Thank you for completing your daily problem. Make sure you take a screenshot of your work, upload it to Google Classroom Post. Make sure you completed all the questions in your Ed puzzle, and you are good for today. Enjoy, guys. See you soon.